Now we're on to some special kind of factoring. Before we had the basic kinds, greatest common factors, simple quadratics, and factoring by grouping. And now these are some special kinds that will use a similar pattern that we'll see how they factor, and we'll use that to factor other kinds. And those are difference of two squares and then the sum and difference of two cubes. And so we'll go ahead and I'll show you that right here. So this is a squared minus b squared. So difference meaning subtraction of two squares, meaning both of those things are squared, a squared and b squared. So a squared minus b squared we call the difference of two cubes. And it equals, when you factor, it factors this way. A plus b and a minus b every single time. And we'll follow that pattern to factor other things that are similar. Here's the sum of two cubes. This factors as this is a cubed plus b cubed. So sum, meaning plus, of two cubes are both cubed. This is a plus b. And in the other parentheses is different than here, is a squared plus a times b plus b squared. Actually, scratch that. That should be a minus. Okay, so a plus b, and then the other parentheses is a squared minus ab plus b squared. We'll use this again later. And the other one is like it, except for instead of a plus b, it's going to be a minus b. And instead of minus a times b, it's plus a times b. Again, we'll use this. We'll see this later. Okay, so here I come down to some ones that I'm going to factor, and I need to identify, first of all, there is no greatest common factor here. I can't factor it that way. It's not a simple quadratic. I can't do it that way. And it's not grouping. There's not four terms here for me to work with. I can't do it that way. So I need to check to see if it fits one of my special cases. So the first thing is it a square or is it a cube? Okay, I have two of them, so that means it could be one of my special cases. That's good. So if I look here, are either of these something squared or cubed? Well, if I look at 16, if it's squared, that means I can take the square root. The square root of 16 is 4. So yeah, it's something squared. It's not something cubed. I can't take the cube root of 16. It comes out to some weird decimal. So if it's anything, it's going to be the difference of two squares. So then I got to go, okay, is this something squared? X to the fourth is x squared squared. So yes, it's something squared as well, and it is a difference. This is the difference of two squares. I could rewrite this as x squared squared minus 4 squared. Okay, so x squared squared would be 4, and 4 squared would be 16. I want you to see that my a in this case, because it's a squared minus b squared, my a is x squared, and my b is 4. My b is 4. So if I follow this pattern, a plus b, a minus b, it just is x squared plus 4 and x squared minus 4. In other words, I take the square root of both of these, I put them in both of the parentheses, and then I just change the sign that's between them. So that is the basic idea of factoring when it comes to the difference of two squares. Now, you need to be careful though, because sometimes you might factor and see that one of the things that you factored can be factored still some more. If I look here, x squared plus 4, well, that's the sum of two squares. X squared is something squared. 4 is 2 squared. Well, I can't factor the sum of two squares. It's not there. It's not on the list. It's not possible. But I can factor this because this is the difference of two squares. X squared is a square, and 4 is a square. So I need to do that last step. So x squared plus 4, that stays the same. And then the next step is to factor that. And this is x squared minus 2 squared. Okay, so basically if I take the square root of both, that's the square root of x squared is x. The square root of 4 is 2. So I have x and 2, and 1 is plus, and 1 is minus. And so now I have fully factored this problem. Fully factored it. Okay, so sometimes you'll factor once and then see that you can still factor again, and you need to keep doing it until you can no longer do that anymore. Okay, moving down to these here. One of these is factorable and one is not. And as I look at both, I see a third power, so I immediately am thinking either sum of two cubes or difference of two cubes. And as I look at it, they're both minus, so it's got to be difference. So now I got to check to make sure that the numbers, I can take those cube roots. If I look at 27, the cube root of 27 is 3, so I can take the cube root. If I look at 25, I can't take the cube root. I can take the square root is 5. But I can't take the cube root, so there's no way to factor this. Because this is a cube, and this is a square. There is no cube and square combination. Now, if I look at this one, the cube root of 125 is 5. So in other words, this is 3m to the third power, because 3 to the third is 27. And m to the third is m cubed. And minus 5 to the third, because the cube root of 125 is 5. So 5 cubed is 125. Okay, so this is like my a cubed minus b cubed, but instead of a, I have 3m, and instead of b, I have 5. So I'm going to follow the pattern that's here. This equals, the first thing it says is a minus b. So 3m is my a, b is 5. 3m minus 5. So that's my first part. A squared is next. A squared. So a squared would be 3m squared, or 3m times 3m. 3 squared is 9, and m squared is just m squared. Plus, so I put a plus, and always just follow the symbols that are here. Okay, whenever you're doing it, just follow the symbols that are there. A times b, 3m times 5. 3m times 5 is 15m. Okay, 3m times 5, and then last, b squared, which is 5 squared, which is 25. Now, there are almost no cases where this is factorable. And you can take a look, you can try to factor that by grouping, but I guarantee you it will not work. And so there you go. There's my factoring by, this is a difference of two cubes. This one was a difference of two squares. If this had been in a plus sign, all that would change in my answer, that would change to a plus, that would change to a minus, because I'd be following this pattern rather than that pattern. Okay, so now when it comes down to it, the difference of two squares, you're going to have to remember that pattern. One's plus, one's minus. The sum and difference of two cubes, I will write down this formula for you on a test if you ever see it on a quiz or anything like that. I will write it down for you because we won't be using it much, especially until later.